Good day, ladies and gentlemen. It's Mr. Nambane. Thank you very much for being a part of our series of videos that we are doing for physical sciences, and we really appreciate all the support you've given us. Kindly subscribe and follow us on Facebook. Everything, it's Nambane Academy. Like I did say earlier on, the numbers are growing. So with that, it means basically you are enjoying the content that we are giving you guys out there. In the description, I will also include a link to our WhatsApp group where you can join and then get immediate PDFs or documents of these lessons that we are currently doing. So if you want to be a part of our WhatsApp group, especially for grade 12 learners, kindly join that link, then everything will be fine. And now we're currently busy with a series of organic chemistry, where the first one was naming and structures, the second one was physical properties and chemical properties. So now this video focuses more on organic reactions. So it basically says to me now, the organic molecules that we spoke about can undergo different types of reactions. So what different types of reactions do we have? So I will start at my epicenter and say now this will be now my organic reactions. So what types of organic reactions do we have? I will start by saying we have one that is called now substitution. We have another one that is known as addition reaction, and then we have another one that is known as elimination. So now with all these three, the question will be, how best can one be able to identify that which organic molecule will undergo addition, substitution, as well as elimination thereof? So it says to me, before I can understand what is substitution, or before I can easily think of which organic molecules will undergo addition, I need first to give what is a substitution reaction. So a substitution reaction is a reaction in which an atom or a group of atoms in a molecule is replaced by another atom or a group of atoms. So this is the definition as per exam guideline. Let's try and find a way of highlighting key points here. So it is a reaction, that one we know, in which an atom or a group of atoms in a molecule is replaced. So it means now it's a substitution. We are just replacing, we are not taking anything away from it, by another atom or a group of atoms. So what does this basically say? It says to me, for substitution to take place, it means now I must be working only with saturated compounds. So for substitution to take place, it means I must work now with a saturated compounds or saturated organic molecules. So what are these saturated molecules? Remember, we said this must now have only single bonds. So if they have single bonds only, what is it that I am looking for? It means I am looking now for an alkane. It's easy for that to undergo substitution. I am also now looking for haloalkanes, and the other one here can be our alcohols. Why? Because all this, even if all alkanes, haloalkanes and alcohols, they contain now single bonds only. So the reason why I will say, if I am looking or talking of a substitution reaction, it means I can only be focusing on saturated organic molecules. So saturated organic molecules is molecules that contain or consist of only single bonds. So if that is the case, it basically says to me, whenever I am looking or I trying to identify a reaction where substitution is taking place, it means now it must move from what I say it's saturated to saturated. That must be now substitution. So we are moving from a single bond to another single bond. Then that reaction must be substitution reaction. Because remember, from the definition, we are only replacing. So it means if I was still having a single bond, I will still continue having the single bond. But now what about addition reaction? So with addition reaction, we define addition reaction as a reaction in which the double bond in a starting material is broken and elements are added to it. So that's the definition of what is addition reaction. So a reaction in which the double bond, so I must add here the double bond in a starting material. This can be an organic molecule. So this organic molecule must be a double bond, must be an alkene in this instance. So one will ask, should we know about triple bonds also undergoing addition? It is not part of our syllabus. The reason being, as per the exam guideline, as per terms and definitions, as per CAPS document, it only says addition reaction is a reaction in which the double bond in an organic molecule is broken and elements are added to it. So it basically says for addition reaction to take place, the only thing that I must be looking for, it must be now an alkene. So an alkene will only undergo addition. So an alkene in this case we say now when I am moving from an alkene which is unsaturated, so when I move from unsaturated to saturated, because now I am breaking down the double bond, that reaction must be addition reaction. So it will always be an issue or a key idea of where is my reaction starting. If it's starting from unsaturated to saturated, that reaction must be an addition reaction. So we will go further and break all these substitution reactions so that we can understand how each one of them will occur. So here we are just breaking out the overview of how are these organic reactions explained. How best can one understand what is substitution, what is addition. So for a reaction to be undergoing an addition reaction, it must be an unsaturated hydrocarbon. So if it's an unsaturated hydrocarbon, it means it must be an alkene. So once I see an alkene, the chances are that organic molecule will undergo addition reaction. Clear? I believe so. So when we get into explaining each one of them, we will now explain the different types of reactions that we have. So let's explain what is elimination. So elimination is a reaction in which elements of the starting material of the organic molecule are lost and a double bond is formed. That is very, very important. So elimination, a reaction in which elements of the organic molecule are lost and a double bond is formed. This is very, very important. When a double bond is formed, it means now we are moving from saturated to unsaturated. So for us to form a double bond, it means we are losing elements of the organic molecule. So for elimination to take place, it means now in simple terms, it must move now from saturated to unsaturated. Then that reaction must be elimination. So it's very, very important for us to understand that. So these are types of reactions we have. So we are going to go deeper into explaining each and every one of them. And the easiest way is just check what is my starting organic molecule. So if my starting organic molecule is saturated, the chances are it is going, and it's the product thereof that is formed, it's also a saturated organic molecule. So the chances are that reaction must be a substitution reaction. The type of substitution reaction will follow. Now once we say now for addition reaction, it means we must start with unsaturated, that is now double bond, moving to a single bond. The chances are that reaction must be an addition reaction. So if we start from saturated and we move now to unsaturated organic molecule, it means that reaction must be elimination. So I want us to understand these basics first before we can try and explain the different types of organic reactions we have. So on the next slide, I am going now to talk only of a substitution reaction and maybe make few examples of it. So let's start now with substitution. Substitution. So now with substitution, we said we can have substitution of an alkane, we can have substitution of a haloalkane, and we can have now a substitution of an alcohol. Remember, what did we say? We said now it must start now from saturated to saturated, then that reaction must be substitution. So all this, we classify them as saturated because they only consist of single bonds. So I am going to start with the first one, which will be a substitution of an alkane. So let's start to say now at A we have substitution of alkanes. Substitution of alkanes. So in a substitution of an alkane, this is what is going to happen. Consider having an alkane which is ethane in this case. So for it to undergo substitution, it means we must now have something that it will react with. So let's have plus Cl and Cl, that is now our chlorine. It is going to form, let me remove this. It is going to form C H C H as well as Cl plus now HCl. So what did we basically do? The only thing that we did was we replaced one hydrogen with one chlorine as per definition. So it can sit on either carbon 1 or carbon 2, but when we name, remember, it will always get the smallest possible number. So in this case, it does not really matter which hydrogen you substitute on. Maybe to avoid confusion, I must just maybe remove this, and then use a different color pen. So this will be 1 and then this will be 2. Remember, we still have our bonds here. So in so doing, this will be our substitution reaction for an alkane. But this reaction, will it take place on its own? No, it will not, because we have what we call reaction conditions. And guys, with reaction conditions, this is very, very important. So what do we need? We need now to have heat or sunlight. So this is an important reaction condition of us understanding a substitution reaction. So if I am starting from an alkane to a haloalkane, because I am moving now from saturated, this one is also saturated, so there's this reaction here, it must be a substitution reaction according to this analogy that we made. So by so doing, it says to me, I need now to know the reactants, which will be this. Then I need also, these are reactants, I need also to know the products that will be formed. I also need to know the products that will be formed. So that is very, very key, because the examiner can either give me the reaction condition and a product. Then I need to know what is the starting organic molecule or the reactant thereof. Or I can be given a reactant with a reaction condition. Then they expect me now to give the reaction product. So in this manner, once I am able to pick it up that I am working with a substitution reaction, then it becomes easy, because I will know that if I start from saturated to saturated, then that reaction stands a better chance of becoming a substitution reaction. So that is very, very, very important. So that is now the first type of substitution that we have. So if this is what is happening, we call this reaction halogenation. So halogenation. So this is if the examiner asks what type of substitution is an organic or reaction X is undergoing, then because they said substitution already, it means we need to give them this explanation here. So I'm going to write it in yellow for emphasis. So halogenation is the type of substitution. It's the type of substitution reaction. This is very, very important. Very, very important. So you cannot say it's a substitution whereas you are told that it is a substitution reaction. So you cannot do that, because already you are told that this is a substitution reaction. So why will you say it's a substitution again? So if they ask you that what type of substitution it's taking place at this specific reaction, then it's very easy. You need to tell them that the only thing happening there must be halogenation. So now I am going to move to another section. In this section, I'm going to just explain now substitution of haloalkanes. So substitution of haloalkanes. Let's remove this. So for substitution of haloalkanes, now we know why haloalkanes will undergo substitution reactions. So this should be B as well. So this is B, substitution of haloalkane. So for substitution of a haloalkane, there are two ways of doing it. The first way, it's an easier way, because we will start now with C, Br, H, and another H. But what can we do to this? We can add a base. Let's add sodium hydroxide. So the product that will be formed will be an alcohol. So we are going to have COH, H, 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 H plus NaBr. So NaBr. Look at this reaction carefully. So when we look at it carefully, it says this reaction, because it's a substitution reaction, we also need to have heat. That is key. We also need now a certain condition of the sodium hydroxide that I am using, the base that I am using. Is it a dilute base or a concentrated base? Because it's substitution, we are going to say we also need to have a dilute strong base. Dilute strong base. So it easily says to me, this now should be my reaction conditions for this reaction to take place. So for this reaction to take place, I need heat, I need dilute strong base, then the reaction will be able to take place. So there are two ways of doing it, as I did say first. So this will be number one. Let's look at number two. What else can I do? So I am going to start again with the very same organic molecule, CBr, H, 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 and then another H. But in this instance, I'm going to add now H2O. So when I have H2O, it's going to give me COH, H, 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 and then plus now HBr. I want you to see this. So this water that I am using, it must be a lot of it. So I need to have excess water, and I also need to have heat. So this reaction as it is, the fact that I am moving from a single bond to another single bond, forming an alcohol, it's a substitution reaction. Because when we go to addition, you will see that once we see water, people will associate water with addition reaction, which is hydration. So that is not the case, because we need to check what is it that water is reacting with. So if water is reacting with a saturated organic molecule, that reaction must be substitution reaction. Very, very important. So it does not necessarily mean wherever you see water, then that reaction must be addition reaction. For to outline that, we say this water must react with a saturated organic molecule. Once it reacts with saturated organic molecule, it allows us to be able to say the product that will be formed, it will be now a organic, it will be a saturated organic molecule. So now this, it's a type of substitution also that is known as hydrolysis. So it's a type of substitution reaction. It's a type of substitution reaction. Very, very important to understand. So once the conditions are excess water and heat, maybe I should also add it here for purpose of emphasis. We need now to have excess water. So once we have excess water and heat, then that reaction will be a substitution reaction. One will ask, will it make a difference if I talk of mild heat and strong heat? I don't want us to go there yet. The reason being, I want us to be able to check that what is our starting organic molecule and what is our product. So once we are able to check the two, it is easy to know whether we are going to need a mild heat or a strong heat, because I am going to make a final summary of how to remember all these complex signs that we are busy talking about. So that will be substitution of haloalkanes. So what do we need? We need to have a strong dilute base or dilute strong base and heat. Let's stop there. Just say heat for us to be safe for now. But now when we add water instead of a strong base, it means we need now to have excess water. So if you check, the same products are being formed. The only thing that is changing is our byproducts that are changing. So if the byproducts are changing, it basically says now we need also to know the reactants as well as the products that are being formed. So this allows me to know exactly what type of reaction I am working with. So I am going now to explain now substitution of alcohols. That is very, very important as well. So we did substitution of an alkane, substitution of haloalkane, and then substitution of alcohol is what we are going to do now. So let's make space so that we now look at substitution of an alcohol. Substitution of an alcohol. So it means alcohol is our starting organic molecule. So I'm going to have my alcohol here. OH. All this you need to know now from the previous video where we explained different organic molecules and homologous synthesis. So in this case, we start with an alcohol. What do we do to an alcohol? We add HBr, then we form an alcohol, a haloalkane, which will be CCBr, H, and then another H, HBr plus now H2O. So for this to take place, we just need heat. Now one will ask, but if we just need heat, we also need heat for a reaction of or substitution of haloalkane. So how best can I identify that this is a substitution of an alcohol? It's easy. You just need to check your byproduct that is formed as well as the haloalkane that is being formed. So you start now from an alcohol which is also saturated. Then you move now to a haloalkane which is also saturated. Then it fits into our description or analogy of saying once I move from saturated to saturated, that reaction must be substitution. So it will be easy for us to understand in detail how best can we be able to work with substitution reactions. So substitution reactions, the only thing we need now is us being able to check the starting point or starting organic molecule, moving to now the product that is being formed. So only these organic molecules will undergo substitution reaction. I think I explained in detail. So I'm going to make a summary. Like I did say, this is just me trying to explain in depth how can we be able to understand that. So now let's go to addition reaction. There's quite a lot to say about addition reaction. So that is now number 2, addition reactions. Addition reaction. So we have different types of addition reaction. I will make my epicenter. So I have my addition, and then I have different types of additions. I have one. The first one will say it's hydration. The second one, it's hydrogenation. Hydrogenation. The third one is halogenation. Third one is halogenation. Halogenation. And the last one, or the fourth one, is hydrohalogenation. Hydrohalogenation. So all these are addition reactions, all of them. So these are types of addition reactions. So it is important that if you are able to pick it up, it's an addition reaction. But how do we make it easy for us to pick up that we are working with addition reactions? Remember, we said if I am working from unsaturated to saturated, that reaction must be addition. So it means I must always now start with a double bond. So once I have a double bond, as per exam guideline and CAPS document, it allows me to fully know that I am going to work with an addition reaction. So if the question comes up and say what type of addition reaction is happening or taking place at this particular reaction, it means I can only say it's hydration, hydrogenation, halogenation, and hydrohalogenation. So let's go into detail and explain each one of them. So explaining each one of them, hydration, we'll start by saying is the addition of water, addition of water to a compound. So addition of water. What is hydrogenation? Addition of a hydrogen to an alkene. Addition of hydrogen to an alkene. halogenation, addition of a halogen Remember, halogen can be Br2, Cl2, I2, and F2. Those are the ones that we work with. Then hydrohalogenation, addition of hydrogen halide, addition of hydrogen halide, say it's your HX, where X can be now Cl, Br, I, and F. So this is very, very important to understand. So these are different types of addition reactions. So we are going to go into detail and explain each and every one of them, and how best will you be able to know and see what conditions do you need for that. So I'm going to add a new page. And then copy it. Then we'll be working with this one. So let's start with hydration. So we start with hydration. So we did say hydration, it's addition of water. So if it's addition of water, let's consider having C double bond C. And then we add now our H2O. What product will be formed? Remember, with addition, we are breaking the double bond. So breaking the double bond will mean I must have only single bonds. And what does that mean? It means I am going to have my OH. I'm going to have my OH, and then I'm just going to have hydrogens around this particular molecule. So what I'm trying to emphasize here is we are moving from unsaturated to saturated with addition of water. But what do we need as our reaction conditions for us to say what condition do we need to work with? We need to have H2SO4, that is sulfuric acid, H2SO4, now as a catalyst. So this is very, very important. There are rules, of course, that governs whether we are going to have a major product or a minor product. So I'm not going to bombard you with that information as yet, because the key of this video is to explain the basic concepts. Once the basic concepts are understood in detail, it's easy for us now to introduce other concepts or other principles that will govern everything that we are doing. Because once the basics are not well taught, it becomes a problem when we now try to answer different sets of questions. So don't worry, you know, maybe this has been taught at your school and the video is not addressing your Markovnikov's rule, your Zaitsev's rule. It's because we are trying to solidify our foundation before moving moving forward, because it's the same as building a house. You must first ensure that your foundation is solid. So once your foundation is solid and stable, is then that you can introduce other things. So what I want us to understand here is we are moving from unsaturated to saturated. Then this must be addition reaction. This is what I want us to understand. This is what I want us to know, that reaction conditions will always be now a part of the reactions itself. So we need to know exactly what are we working with. So I'm going to move now to the second one. The second one, which is halogenation. So halogenation, remember we said it is addition of a halogen. Halogenation. So I'm going to write it down here. Halogenation. That is now the second type of addition reaction. We start also with a double bond. H, 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 and then we add our halogen. In this case, I'm going to add Br, Br. Then the product that is formed will be now C, C, single bond, single bond, single bond, single bond, single bond, single bond. Because from the definition, addition reaction is the breaking down of a double bond to a single bond. So hence I know that everything that is going to be formed here will be a single bond. So what do I need to do? I need to take one Br to this carbon and then one Br to that carbon. So I'm going to have a Br here, I am going to have a Br, and everything else will now be hydrogen, hydrogen. This is very, very important for us. So do we need anything for this reaction to take place? Yes, we need an unreactive solvent. Unreactive solvent. So this unreactive solvent can be anything as long as it's not reacting or forming part of the product that is being formed. So I want us to build a momentum of understanding fully this addition reaction. We are moving from an unsaturated, which is a double bond. We add a halogen, then we form a haloalkane. I want to put my head on the block to say, for halogenation, you will always form something like your 1,2 dibromo, 2,2 dibromo. You will always have the di part of things. Why? Because you are adding a diatomic element. Br. So we are adding a diatomic element. So once we add a diatomic element, it means we are going to have two elements that are introduced or now forming part of the organic molecule. Be aware of that. So once the name is something like 1,2 dibromo, it means that reaction have what was added to it was a diatomic element. So that is very, very important. So let's move to the other one, which is now at number 3. It's hydrogenation. Hydrogenation. So we're going to start again with our double bond. And then add our hydrogen as per definition. Add our hydrogen, which is H2. Then we are going to have a single bonds, single bonds, single bonds. This is key, breaking down of the double bond. So what did we add? We added a hydrogen, 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 and another hydrogen. Is there a reaction conditions that we need? Yes, we need now to have either PT, PD, or nickel as our catalysts. So we are going to need to have PT, PD, or nickel as catalyst. Remember, you must know the formula as well as the name. So this is PT for platinum, PD for palladium, and then Ni for nickel. So that's basically it with this particular reaction condition. But also it's starting from where? Unsaturated to saturated. That is very, very key. So these reaction conditions are going to assist us for us knowing and being able to fully understand the type of reaction that we are working with. So it becomes easy once we have identified what type of reaction is occurring. So let's move to the fourth one, which is now halogenation. Halogenation. Where do we start? We start with a double bond. What do we add? We said we add hydrogen halide. So that hydrogen halide in this case can be HCl. Then what are we going to form? We break the double bond. That is very, very important. Then we attach Cl and then all other hydrogens. Then our reaction has taken place. So what reaction condition do we need? The easiest one is no water. No water. So this is the addition reaction. Now, with this being said, it's clear that each and every one of us should now be in a position of understanding what is addition reactions. So it's addition reactions for the alkenes, which means the double bonds. So summary, unsaturated to saturated, that must be addition. So let's move to the second page. And this page, I want to remove this line here. So after removing the line, I'm going to say for elimination reaction. So we are at number 3, which is now elimination reaction. So elimination reaction, I'm going to start at the center as well. Sorry. So we have elimination reactions. So with elimination reactions, I'm going to have now one, which is known as dehydration. I'm going to have another one, which is dehydrohalogenation. That is number 2, dehydrohalogenation. And then I'm going to have the last one, which is cracking. I'm going to have the last one, which is cracking. So these are now types of elimination reactions. Let's explain each one of them. Dehydration, it's elimination of water from a compound, usually as an alcohol. So elimination of water, elimination or removal, elimination of water from a compound. Let's just say compound. Fine. Then we have dehydrohalogenation, elimination of hydrogen and a halogen. So removal of hydrogen and halogen from a haloalkane. Then we have cracking, which is now defined as the chemical process in which longer chain hydrocarbon molecules are broken down to shorter, more useful molecules. Now, dehydration, dehydrogenation, and cracking. So elimination of water from a compound, elimination of hydrogen halide from a haloalkane. Then the other one, it's a process in which longer hydrocarbon molecules are broken down. So this hydrocarbon molecule that we are looking or the definition is referring to, in most cases it will be alkanes. So our focus will be only in alkanes. So we move from an alkane, we break it down. So when we get to it, I will explain fully what is going to happen with that. So this one, maybe I can just write it here. It will be just removal of water, that is dehydration. So I must maybe go here and then copy this, and then we say we are at number 1. Okay, sorry, we are at number 1. Number 1, it's dehydration. So for dehydration to take place, we must start with an alcohol. So alcohol, it's COH, and then we move to H2O plus the double bond being formed. The double bond being formed. So it makes it easy. It makes it easy for us to understand elimination is just the reverse of addition. So H and another H. So what do we need here? We need a dehydrating agent. Dehydrating agent, and this dehydrating agent, it's either H2SO4 or H3PO4, and we also need heat for this reaction to take place. We also need heat for this reaction to take place. So this is dehydration, removal of water. Then we can go now to number 2. Number 2, okay, let's add number 2 here. It's dehydrohalogenation. So at number 2, it's dehydrohalogenation. We need to know all these heavyweights. So we start with a haloalkane, Br, and then we add sodium hydroxide, and then we form our double bond, plus we form sodium Br plus H2O. So this is dehydrohalogenation. Reaction conditions, we must use now concentrated strong base. Concentrated strong base and heat. Just going to say heat for now. And heat. Then the third one, at number 3, it's cracking. It's cracking. So with cracking, I'm going to do 2 examples of it. The first one is, let's have 1, 2, 3. We said it must start from a hydrocarbon. So what are we going to do here? We are going to have high pressure and high heat. Let's just say high heat. So we are going to break this down. So if you are going to break this down, So the products that will be formed, it's okay, we need another H here. We can form an alkene and an alkane. So I'm going to form an alkene and alkane in this case. That is the first one. I'm going to form my double bond. So for me to form a double bond, I obviously need 2 carbons. So this is my alkene plus, now what else must be there? CH4. So this becomes cracking because we are breaking down the longer chain into shorter chains. So let me clean it up. Then we add another hydrogen. So what did we do? Product number 1 is we can have an alkane that will now give us an alkene plus another alkane. That is situation number 1 according to this particular example. So I'm going to give you another example of a very same cracking. So let's go to B. B, I'm going to use now CCC, the very same hydrocarbon, and then expose it now to high pressure and high heat. So what product will be formed? I said I want to form H2 gas plus I must form a double bond now. So whichever one does not really matter, but a double bond must be formed. So I can form the double bond here, then this will have H, then H, and then just H here, and then this one will have 3 hydrogens. So what did we do? We moved now from an alkane to alkene plus hydrogen gas. So this is very key for each and every one of us to understand. So depending on the products that are formed, it is easy for us to pick up what type of the products formed from cracking. So this is basically elimination reactions. So with elimination reactions, if you check, we are starting now from saturated to unsaturated. That reaction must be elimination reaction. We are starting with an alcohol that is saturated. We form a double bond. We start with a haloalkane that reacts now with sodium hydroxide to give us an unsaturated ethene. Then we start with a hydrocarbon that will give us now an alkane and alkene. This is this part here. And then we start now with an alkene that is saturated. We get now an alkene and a hydrogen gas. So it basically says it is important now for us to be able to know where is the reaction or what are the starting reactants, then the products that are being formed. So we spoke of substitution, we spoke of addition, we spoke now of different types of elimination reactions. So I'm going to make a very quick summary of how best can all of us now comprehend everything that we spoke about today. Key basic things that each and every one of us must do. So now this is a summary of, maybe we can say, exam tips of what to look for. This is now for the exam tips. Now the first one is reactions. The first one is reactions. So with reactions, what we do is we are going to try and have a summary of these reactions. So a good friend of mine, Bishop from Crazy Physics, he showed me this analogy on one of the videos we did. So credit to him for doing the great job. So remember, we work as a team. No man is an island. So this analogy was shared to me by Bishop from Crazy Physics. So we work in hand in hand. So we try to give you the best possible way of assisting you. So what the analogy says is, imagine me as single and seriously searching. Then I went to the United States of America. I met a beautiful lady called Sue. How does this now relate to science? I was single and seriously searching, went to the United States of America and met a beautiful lady called Sue. What does that mean? It says to me, if I'm working from saturated to saturated, that reaction must be substitution. If I am working now from unsaturated to saturated, that reaction must be addition reaction. If I am working from saturated to unsaturated, that reaction must be elimination. 100%. So how best can I remember the reaction conditions? 2. Reaction conditions. And the easiest way is, because now I met a beautiful lady called Sue. By grace, God gave us now 4 children. It's a happy marriage, eh? So now, what does this mean? It means now when I see C for concentrated, then the reaction must be elimination. So already it is saying to me, if I am looking at the reaction and I am told that concentrated strong base was used, then that reaction must be elimination. If I am told that dilute strong base was used, then that reaction must be substitution. That reaction must be substitution. So already I will not have a problem of if I am given a condition of concentrated strong base, dilute strong base. Already, if it's dilute, that reaction must be substitution. And if it's substitution, it will feed now to this triple S here. So already, I will know what type of product is going to be formed. I will know what type of organic reactants I am going to get. Also, if it says concentrated strong base, already it says to me I am going to know that reaction must be elimination. So for it to undergo elimination, I must start now from saturated to unsaturated. What about heat? We say now we have mild heat, not mild heat, let's just say heat. We have heat, so we can have now mild heat and very strong heat. So if it's a mild heat, you burn your finger from a stove, in no time the pain will be gone, né? And your skin will try to reproduce a new layer of skin. So that is mild heat. So it's analogies that we are using. So it means if we are going to work with mild heat, that must be substitution. That must be substitution. It's mild, you burn your finger on the stove. In few days, the layer of your skin has peeled off, and then the skin is trying to reproduce another layer of skin. It's substitution. But now imagine if it's strong heat. If it's strong heat, the chances are you are going to die or burn, and then it will take you time for your skin to reproduce that. So for strong heat, then it must be elimination. So once they ask me what type of or give reaction conditions for elimination, once I have identified its elimination, then the two ways of giving them will be I need strong heat. I also need to have concentrated strong base. Remember, this here now, for emphasis, focuses now on strong base. This now focuses on strong base, and this focuses now on heat. So I will not have a problem when giving reaction conditions for either substitution and elimination. So for substitution, it's dilute strong base and mild heat. For elimination, it's concentrated strong base with now strong heat. 100%. Then I will not have any confusion. And this already strong and mild, they are going to assist me in terms of differentiating between the two, because now why? I am starting from saturated and I'm also starting from saturated. Now I need something extra to allow me to know exactly what product will be formed. Is it going to be substitution? Is it going to be elimination? So it means now I need a reaction condition for that. So a reaction condition, once I am told it is concentrated strong base, definitely it must be for elimination. Then I'm going to move for saturated to unsaturated. If I am told it's dilute strong base, then it must be substitution. Then I'm going to move from saturated to saturated. Definitely it must be substitution. Once I understand that fully, it allows me to be in the right direction of answering the questions. It allows me to be in the right direction of the prediction of things that I need now to be looking for. So kindly take this analogy, this summary, as part of your preparation, together with the definitions and other things, of course. So this becomes a nice summary of how to identify different types of reactions. So I'm going to add this one on summary. It's a type of reaction as well, but I usually add it here because it's easy, this one, for us to understand. It's called now combustion. Combustion. So combustion is basically a reaction in which now an alkane reacts with oxygen. I will write it in words. You have your alkane reacts with oxygen, then it gives you carbon dioxide, it gives you water plus energy. So basically it says it is an exothermic reaction because energy is released. You need to understand that. So it is an exothermic reaction. That is from grade 11. It is an exothermic reaction from grade 11. So we need to fully understand that. So I'll write here, it's an exothermic reaction. It's an exothermic reaction. So alkane can be anything. C6H14, oxygen is O2, then it's going to give us carbon dioxide, which is CO2, plus water, which is H2O. Then I must balance. I think I need 2 and then 19 and then 12 carbon dioxide and then 14 H2O. So balancing is also from grade 10. I won't waste the time explaining that. My point is, for combustion, full combustion, that is what CAPS document says. We must just know full combustion or a complete combustion. So for a complete combustion, we will always have now carbon dioxide, water, and energy being part of our products. That one will be easy, 3 marks for us to get. But the 3 marks will also come with the balancing. So for me to be given a mark, I need to have the reactants. I also need to have an arrow. I also need to have my products and including the balancing as well. So it will be 1 for the correct reactants, 1 for the correct products, and then 1 for balancing. So it will always be something around 3 marks. So please look into this. This is just an easy other reaction that we just need to know. Then the most complex things have been done. So I think this brings us to the end of the topic. So we are going to have another session, obviously, like we normally do, where we take exam types of questions, and then with exam type of questions is where we see now how best can we apply this. So we cannot attempt exam questions before the foundation is solid. So from me to you, thank you very much for all the support. Don't forget to subscribe and like the videos. Leave a link. Like I did say in the description, I'm going to add our WhatsApp group page or link. Then you can just join from the link. Then automatically this PDF, this summary of notes, it's what you will immediately get. So you can share with everybody, talk the science, because that is what we normally don't do. We don't discuss the science, we discuss other things. So talk the science, try to understand and visualize yourself as someone who's going to set a paper, that we are not going to ask the very same questions over and over again, but what are we going to do? We are going to try and ensure that we ask questions in such a way that concepts have been applied fully. So from me to you, thank you very much, and let's meet on the next one.